Welcome to the facility. Today, we're looking at how we make Lifebuoy. It all starts with high-quality, rendered beef tallow.
At first glance, a bar of soap seems like one of the simplest products in modern life. Smooth, solid, clean, and familiar, it sits quietly in bathrooms around the world. Yet behind that simplicity lies a surprising origin story, one that begins far away from laboratories and packaging lines, at the very foundation of the raw materials themselves. For Lifebuoy, the journey starts with an ingredient many people would never associate with personal hygiene at all: beef tallow. Beef tallow is a natural fat derived from cattle, long valued for its stability and rich fatty acid profile. Historically, it has been used in candles, cooking, and soap making for centuries. But the tallow used in industrial soap production today is a far cry from its crude origins. Before it can ever become part of a Lifebuoy bar, it must undergo a rigorous transformation, one that turns a raw, animal-based material into a purified, cosmetic-grade fat, suitable for daily contact with human skin. The process begins at approved sourcing facilities, where beef fat is collected under strict hygiene and traceability standards. Only fat that meets predefined quality criteria is accepted. From there, time becomes a critical factor. Freshly collected tallow is quickly transported to refining facilities to prevent oxidation and microbial degradation. Even at this early stage, quality control teams are already at work, testing acidity levels, moisture content, and impurity ratios. One small deviation could compromise everything that follows. Once inside the refinery, the real transformation begins. The raw tallow is first heated gently until it melts into a liquid state. This controlled heating allows solid impurities such as connective tissue, residual proteins, and debris to separate from the fat. Mechanical filtration systems then remove these unwanted materials, leaving behind a clearer, more uniform liquid. But clarity alone is not enough. Next comes neutralization. Natural fats contain free fatty acids that, if left untreated, can cause unpleasant odors, instability, or skin irritation. By carefully introducing neutralizing agents, technicians reduce these acids to acceptable levels. This step requires precision. Too much treatment can damage the fat structure, while too little leaves impurities behind. Every adjustment is monitored digitally in real time. The refining process continues with bleaching and deodorization. Using safe, food, and cosmetic-grade absorbent materials, pigments and trace color compounds are removed. What was once a yellowish, uneven fat gradually becomes pale and clean. Deodorization follows, carried out under vacuum conditions at specific temperatures to strip away lingering odors without altering the fat's beneficial properties. By the end of this stage, the tallow no longer resembles its original form in smell, appearance, or behavior. What emerges is refined beef tallow, stable, neutral, and consistent. It is this refined fat that makes it valuable for soap production. Its molecular structure allows it to produce a hard, long-lasting bar with excellent cleansing performance and a creamy lather qualities consumers often take for granted. Yet achieving this reliability requires not just chemistry, but discipline. Before the refined tallow is approved for the next stage, it undergoes another round of testing. Samples are analyzed for purity, oxidation stability, melting point, and microbiological safety. Only batches that pass every parameter are released into the soap-making line. Anything less is rejected, reprocessed, or discarded entirely. At this point, the ingredient is ready, but the product is not. The refined fat is merely the foundation, the silent backbone of what will eventually become a bar of Lifebuoy soap. Chemistry, science, and branding have not yet fully entered the scene. That moment comes next, when purified fat meets a powerful counterpart in a reaction that has defined soap making for generations. So the question is, what happens when this carefully refined tallow finally encounters alkali in the heart of the factory? And how does a chemical reaction turn purified fat into something that can protect millions of families from germs every single day? With the beef tallow now fully refined, purified, and approved, the process moves into a stage that can only be described as the heart of soap production. This is where chemistry takes center stage. Inside massive stainless steel reactors, the refined fat is no longer just an ingredient, it is about to be transformed. This transformation is called saponification, and without it, soap simply would not exist. The refined tallow is pumped into large reaction vessels designed to withstand heat, pressure, and continuous agitation. Here, it meets its chemical counterpart, an alkaline solution, typically sodium hydroxide.
Looks good. We are clear for
On
packaging.
paper, the reaction looks simple. Fat plus alkali equals soap and glycerin. But in reality, this step demands absolute precision. Timing, temperature, concentration, and mixing speed must align perfectly, or the result can be unstable, harsh, or ineffective. As the alkali is slowly introduced, the mixture begins to change. The once clear liquid becomes opaque and thicker, signaling that the chemical bonds of the fat molecules are breaking apart. Triglycerides split, releasing fatty acids that immediately bond with sodium ions. This is the exact moment soap is born at a molecular level. The process releases heat, so temperature sensors constantly feed data into automated control systems to prevent overheating or incomplete reactions. For a brand like Lifebuoy, this step is non-negotiable in terms of consistency. Every batch must behave the same way, regardless of production volume. A reaction that runs too fast may trap unreacted alkali inside the soap, while a slow or uneven reaction can leave behind free fats that affect cleansing performance. That is why modern soap plants rely on computer-controlled reactors rather than human judgment alone. As saponification progresses, a valuable byproduct begins to form: glycerin. Naturally released during the reaction, glycerin is known for its moisturizing properties and is widely used in cosmetics and pharmaceuticals. In many industrial setups, glycerin is carefully separated from the soap base through controlled settling or centrifugal systems. Nothing is wasted. What started as a chemical necessity becomes an asset. Meanwhile, the soap itself continues to mature inside the reactor.
Perfect. Drop it
Agitators
right there and
ensure
grab the next one.
uniformity, preventing layers or inconsistencies from forming. The mixture thickens into what is known as neat soap, a concentrated soap base that still contains excess water and residual impurities. At this stage, the soap is functional, but far from finished. Quality checks intensify here. Technicians sample the mixture to test alkalinity, viscosity, and reaction completeness. Even minor deviations can have serious
A little more to the
consequences
left.
later, from skin irritation to
right,
poor
hold it
shelf
right
stability. If results fall
Set your
outside
brake.
strict parameters, adjustments are made immediately, sometimes by adding more alkali, sometimes by extending reaction time. In rare cases, an entire batch may be held back for reprocessing. What makes this stage especially critical is that mistakes made here cannot be fully corrected later. Fragrance, color, and antibacterial agents may enhance a soap, but they cannot fix flawed chemistry at the core. Saponification determines
three
the
more
soap's
pallets of the
cleansing
Lifebuoy
power,
on dock
hardness, and
Copy that.
compatibility with
Moving it
skin.
now.
It is the invisible architecture beneath the brand. Once the reaction reaches completion, the mixture is allowed to stabilize. Excess heat dissipates, and the soap base becomes chemically balanced. Only then is it ready to move forward, leaving behind the world of raw chemistry and entering a phase where science meets consumer experience. But here lies the twist. Even after soap has technically been made, it still lacks identity.
Okay, he's
No
lined
color,
up. Get the chalk
no
ready.
scent, no signature antibacterial strength.
Bill of lading
So
says
how does this
22
neutral
pallets of
soap
Lifebuoy.
base become the unmistakable Lifebuoy bar recognized across generations? That answer awaits in the next stage, where formulation, protection, and brand identity finally come together. The soap now exists. Chemically speaking, it is real, functional, and capable of cleaning skin. But here is the truth many people never consider. At this stage, it is still just soap. It has no personality, no signature scent, no recognizable color, and most importantly, no defining purpose. Have you ever thought about what truly separates one bar of soap from another? This is where the answer begins to unfold. Once the saponification process is complete, the neat soap base is transferred into large formulation mixers. These machines are not simply blending equipment. They are where science, branding, and consumer trust converge. Inside them, the neutral soap base becomes a carefully engineered product designed for protection, familiarity, and consistency. At this stage, formulation specialists begin adjusting the soap's internal balance. The pH level is fine-tuned to ensure it is effective against germs while remaining safe for frequent human use. Even a slight imbalance could mean the difference between protection and irritation. Have you ever wondered why some soaps feel harsh, while others feel reassuringly gentle? The answer lies in these invisible adjustments. Next comes the defining element: antibacterial agents. For Lifebuoy, this is not just an additive, it is the brand's identity. These agents are introduced in precise quantities, measured down to fractions of a percent. Too little, and the soap loses its protective promise. Too much, and it risks skin discomfort. This balance is achieved through decades of research, testing, and refinement. But antibacterial power alone does not make a soap memorable. Color pigments are added next, giving Lifebuoy its instantly recognizable appearance. These pigments are cosmetic grade, stable under heat and pressure, and carefully chosen to remain consistent across millions of bars. Have you ever noticed how the color of a Lifebuoy bar never seems to change,
Have a great day.
no matter where or when you buy it? That consistency is not accidental, it is engineered. Then comes fragrance. Scent is one of the most powerful triggers of memory, and soap manufacturers understand this deeply. The fragrance added at this stage is not simply a smell, but a carefully constructed sensory experience. It must survive high temperatures, mechanical stress, long storage times, and daily use while still evoking cleanliness and protection. Have you ever thought about why a single whiff of soap can instantly remind you of home, childhood, or safety? As all these components come together, the mixture is blended under controlled conditions to ensure perfect uniformity. Massive paddles rotate slowly, folding antibacterial agents, fragrance, color, and soap base into one seamless mass. There can be no pockets, no uneven distribution. One bar must perform exactly like the next, whether it is used today or 6 months from now. During this phase, quality control becomes relentless. Samples are constantly extracted and sent to on-site laboratories. Scientists test antibacterial efficacy, pH stability, texture, and even scent retention over time. Did you ever think that a bar of soap would be tested as rigorously as a pharmaceutical product? In many ways, it is because it interacts with human skin every single day. Only after passing these evaluations is the soap approved to move forward. At this point, it finally earns its name. It is no longer just soap, it is Lifebuoy. Yet, despite its newly defined identity, it still lacks one crucial thing: form. Right now, this soap exists as a uniform, shapeless mass. No logo, no familiar curves, nothing you could recognize on a store shelf. So here is the question: how does this carefully formulated substance transform into the solid, iconic bar that fits perfectly in the palm of your hand? The answer lies ahead, in the next stage where pressure, precision, and machinery give Lifebuoy its final shape and physical presence. Up to this moment, Lifebuoy exists as a perfectly formulated substance, but not yet as a product you can recognize. It has no edges, no logo, no weight in the hand. It is effective, tested, and approved, yet still invisible to the consumer. Have you ever wondered when soap actually becomes a bar of soap? The answer lies in this stage, where science gives way to structure and chemistry finally takes shape. The journey begins with drying. After formulation, the soap mass still contains excess moisture, which makes it too soft and unstable for shaping. To solve this, the soap is transferred into vacuum drying systems. Under reduced pressure and controlled heat, water is gently removed without damaging the soap's internal structure. This step is critical. Too much moisture, and the bar will deform over time. Too little, and it may crack or crumble. As moisture levels drop, the soap transitions into a dense, pliable material firm, yet workable. Did you ever think that the hardness of a soap bar is something that must be engineered, not guessed? Every percentage point of moisture is measured and logged, because consistency here determines how the product will perform weeks or even months later. Once dried, the soap moves into extrusion, often called plodding. This is where the material is forced through powerful screw-driven machines that compress and refine it further. The pressure removes trapped air, aligns the soap's internal structure, and produces a smooth, continuous bar of solid soap. At this stage, the soap finally resembles something tangible, long, uniform, and ready to be shaped. But extrusion does more than just change appearance. It improves texture, ensuring that the soap feels smooth against the skin rather than grainy or brittle. Have you ever noticed how a quality soap glides easily in your hands instead of scraping or flaking? That sensation is created right here, under intense mechanical precision. The extruded soap is then cut into individual segments, each one weighed with extreme accuracy. Even a small deviation in weight can affect consumer trust and regulatory compliance. Bars that fall outside tolerance are automatically rejected long before they ever reach packaging. Next comes one of the most recognizable moments in the entire process: stamping. Each soap segment is placed into a metal mold and pressed under high pressure. In a fraction of a second, the bar takes on its final shape: smooth curves, defined edges, and the unmistakable logo of Lifebuoy embossed on its surface. This logo is not merely decorative, it is a symbol of authenticity and quality assurance. A blurred imprint, a chipped edge, or an uneven surface is enough to disqualify a bar. Did you ever imagine that a soap bar could fail simply because its logo wasn't perfect? In mass production, perfection is not optional, it is expected. After stamping, the bars are cooled and stabilized. This resting period allows internal stresses created during compression to relax, preventing warping or surface defects later on.